Europe will freeze over in the next 50 years. Scientists sound the alarm. Deep in the Atlantic Ocean flows an invisible river, more powerful than all the great terrestrial rivers combined. It's the so-called Atlantic Meridional Overturning Circulation, Amoc for short, which we can't imagine as a gigantic heat conveyor belt that has regulated our planet's climate for millennia and made northern European lands habitable. But today, as we're about to see in this remarkable video, it seems this perfect mechanism is about to break, with consequences that could prove catastrophic beyond our wildest expectations. The Amoc transports about 15 million cubic meters of water every second, a volume equivalent to about 70 rivers the size of the Amazon. To get an idea of its power, we're talking about 15 sphere drops, where each sphere drop equals 1 million cubic meters per second. It's such an immense amount of water that it would fill 6,000 Olympic swimming pools every second. This colossal oceanic river, of which the famous Gulf Stream is just one branch, carries warm surface water from the tropics northward, all the way to the coasts of Norway and Greenland. A flow of thermal energy that creates a temperature difference of over 10 degrees Celsius between this Western Europe and North American regions at the same latitude. Without the system, London would be much colder than Labrador, Oslo would be buried under meters of snow for most of the year, and Scandinavia would be an uninhabitable Arctic desert. And that's why palm trees grow in Cornwall, vineyards thrive as far north as southern Germany, and agriculture flourishes in Scandinavia despite its northern latitude. The Amoc is literally Europe's central heating system, a gigantic natural heat pump that has worked uninterrupted for millennia, allowing the birth and development of Western civilization. Just to be clear about the economic scale, European agriculture is worth about 200 billion euros a year, tourism another 500 billion. All this wealth exists only thanks to the Amoc. Without it, most of northern Europe would have the climate of Siberia. What drives this perpetual motion? Okay, so we have this ring of water in continuous movement. But what's the energy that powers it? The answer lies in the winds. The trade winds, those constant winds that blow from east to west in the tropics at an average speed of 20 to 30 kilometers per hour, are the starter motor of the entire system. These winds push about 150 million tons of water across the tropical Atlantic every day, piling it up against the American coasts. The water, which can't just disappear, finds itself forced to escape northward through passages between the Caribbean islands and around Florida. Here's where the Coriolis Effect comes into play, that invisible force due to Earth's rotation that deflects everything moving in the northern hemisphere to the right. The combination of winds, topography, and Coriolis channels this warm water into a narrow, fast current along the American coast. The Gulf Stream is born, carrying about 30 sphere drips, twice the flow of all the world's rivers combined. The water evaporates as it travels north, driven by the trade winds, becoming ever saltier and colder. When the current reaches the polar regions, Greenland, Norway, Labrador, the Arctic cold chills it further until, since cold, salty water is much denser than warm fresh water, the front of this immense marine river begins to sink down to the level of deep ocean currents. Underwater currents that slowly move south again, where they return to the surface through a process called upwelling. The Atlantic is perfect for this mechanism, narrow enough to allow intense heat exchange between north and south, yet extensive enough to sustain a powerful circulation. The result is a system that has self-sustained for millennia or more. In short, it's like starting a combustion engine. You need the crank to get the first turn going. Then, the engine maintains itself, and the trade winds are the Amoc's crank. Once the mechanism is triggered, the system becomes self-sustaining and can run forever. But we're living in a historical period, you know this, where human presence manages to heavily influence the fragile mechanisms that Mother Earth has refined over millions of years. And so in October of 2024, a document signed by 44 of the world's most eminent climate scientists launched an alarm that shook the global scientific community. the Amoc could stop by the end of the century, plunging northern Europe into an irreversible ice age. An alarm, as we're about to see, absolutely well-founded, documented by a network of 226 instruments scattered across the Atlantic between Florida and Morocco. Researchers from the University of Copenhagen used sophisticated early warning signals based on observational data to predict when the point of no return might be reached. Their statistical analyses, published in Nature Communications, represent a methodological breakthrough that goes beyond simple trend observation. Using advanced techniques for analyzing dynamic systems, they identify the loss of resilience in the Amoc system. The results are staggering. With 95% statistical confidence, the collapse could occur between 2025 and 2095, with the most likely date set at 2057, just 32 years from now. This isn't some distant future, it's the span of one generation. Children born today could see Europe transform into an Arctic continent during their lifetime. But what does Amoc Collapse actually mean? It's not like a natural phenomenon of this magnitude can just stop suddenly, like a faucet being turned off. It's more like a heart that starts beating slower and slower. 15 sphere drops becomes 10, then 5, then 2. When it drops below 4 sphere drops, less than a third of current strength, the effects on European climate become devastating and irreversible. These results are based on detecting scientifically rigorous early warning signals, increased variance, loss of resilience, and increased autocorrelation, critical slowing down, which have recently been reported for the Amoc in real oceanographic observations. It's like measuring the irregular beats of a sick heart before cardiac arrest. The most concerning aspect is the irreversibility of the process. Once the Amoc collapses, it can't be easily or quickly restarted. As the 44 scientists wrote in their urgent letter, such a change in ocean circulation would have devastating and irreversible impacts, especially for Nordic countries, but also for other parts of the world. The letter represents a historic moment in climate science. Rarely have so many world-class experts united to sound such an explicit alarm. It's the scientific equivalent of a planetary red alert. Hey guys, just a moment before we continue. Be sure to join the Insane Curiosity channel. Click on the bell, you'll help us to make products of even higher quality. Simulations also confirm the danger. A few months after this unprecedented alarm, on June 11, 2025, the journal Geophysical Research Letters published a study that confirmed and quantified the scientific community's worst fears. The team, led by Dr. Renee Van Westen from Utrecht University, used the Community Earth System model to simulate in detail what would happen if the Amoc stopped completely, turning theoretical alarm into concrete and deeply troubling numerical scenarios. To run these simulations, researchers used one of Europe's most powerful supercomputers, running models for over 2,000 simulated years. The result? The collapse, or even just a strong slowdown of the Amoc, would transform Europe into a realm of ice. London would see temperatures colder than current Reykjavik in Iceland. Edinburgh, already accustomed to Scottish cold, would experience winters with temperatures down to minus 29.7 degrees Celsius. Oslo would plunge into perpetual winter, with average temperatures of minus 16.5 degrees Celsius and catastrophic lows of minus 48 degrees Celsius, colder than current Arctic temperatures. But the numbers become even more threatening when we look at specific cities. Amsterdam would see average winter temperatures plummet from plus 4 degrees Celsius to minus 8 degrees Celsius. Copenhagen from plus 1 degree Celsius to minus 15 degrees Celsius. Berlin from plus 1 degree Celsius to minus 12 degrees Celsius. And we're talking about averages. Cold snaps would be much worse. Sea ice wouldn't extend to the coasts of Britain and Scandinavia, creating scenarios Europe hasn't seen for thousands of years. The Baltic would freeze completely for 6 to 7 months a year instead of the current 2 to 3. The North Sea would see ice reaching Dutch and Belgian coasts. Parts of Europe could see temperatures drop by up to 30 degrees Celsius from current levels, while the rest of the planet continues warming. It would really be like living in an ice age, commented Tim Lenton, climatologist at the University of Exeter, not involved in the study. But at the same time, extreme summer temperatures would be barely affected. It would be like stepping out of the freezer into the frying pan of summer heat waves. But this is perhaps the most disturbing feature of Amoc Collapse. Winters would become Siberian, but summers would remain scorching. London could go from 20 degrees Celsius in January to plus 35 degrees Celsius in July, a thermal shock of 55 degrees in 6 months. No ecosystem, no agriculture, no society is prepared for such extreme swings. The cause of possible collapse. But what's causing this imminent collapse? The culprit is paradoxically the same global warming we're trying to fight. The accelerated melting of the Greenland ice sheet is pumping enormous amounts of fresh water into the North Atlantic, altering the delicate salt balance that has kept the Amoc stable for millennia. 2024 data paints an alarming picture. Greenland lost 55 gigatons of ice, the lowest level of annual loss since 2013, but still the 28th consecutive year of net ice loss. To get an idea of the scale, already in 1993, Greenland's melting resulted in 300 cubic kilometers of fresh water entering the oceans annually, equivalent to 0.7% of fresh water from all the world's rivers. Today, that flow has tripled. But these numbers hide an even more dramatic reality. In 2012, a record year for melting, Greenland lost 450 gigatons of ice, enough to cover all of Germany with a meter of water. And it wasn't an isolated event. From 2000 to 2020, the average loss was 280 gigatons per year. We're talking about 7,500 tons of ice melting every second. Revolutionary research published in 2024 in the Journal of Climate analyzed 73 years of extreme melting events in Greenland, 1950 to 2022, discovering that extreme melt days represent about 35 to 40% of total accumulated melt per season. Even more disturbing, the frequency, intensity, and contribution to total summer melt shows a statistically significant upward trend at a 95% confidence level. This fresh water doesn't distribute evenly in the ocean. Satellites show it concentrates precisely in areas where the Amoc should sink, the Labrador and Greenland seas. Here, salinity is already decreased by 0.3% since 1990. Seems small, but it's enough to reduce water density by 2%, preventing sinking. This freshwater invasion is catastrophically altering the ocean's salt balance. Freshwater is less dense than saltwater, a seemingly minor difference with titanic consequences. When freshwater mixes with seawater, it reduces its density, preventing the sinking process into the depths that fuels the entire Atlantic circulation. It's like pouring oil into a perfectly calibrated gear mechanism. The Amoc, which has functioned for millennia with atomic clock precision, begins to slow, to jam, until it stops completely. And when it stops, Europe's natural thermostat stops working forever. New research demonstrates this process accelerating. If meltwater is included in climate projections, the Amoc could be 30% weaker by 2040, 20 years earlier than previous predictions that didn't consider this factor. We're literally accelerating toward the climate abyss. But there's an even more disturbing aspect. This process could feed on itself. When the Amoc weakens, it transports less heat north, causing more sea ice formation in the Arctic. More ice means more solar reflectivity, more cooling, more ice. It's a vicious cycle that accelerates its own destruction. Technology comes to our aid. How do scientists see the Amoc in the ocean depths? It's an extraordinary network of technologies monitoring the Atlantic's beating heart 24/7. Satellites measure ocean surface temperature with 0.1 degrees Celsius precision. They can detect water height variations of just 2 to 3 centimeters. When the Amoc weakens, sea level changes measurably. The European satellite Sentinel-6 flies over the Atlantic every 10 days, mapping every change. Below the surface, 3,000 Argo floats drift freely in the world's oceans. diving to 2,000 meters depth every 10 days to measure temperature and salinity. They're like robotic thermometers sending data via satellite. Over the past 20 years, they've collected 2 million profiles of the Atlantic Ocean. The RAPID network uses even more sophisticated technology. Submarine cables measuring the magnetic field generated by moving salt water. When the Amoc slows, the magnetic field changes and sensors detect it. It's like feeling the ocean's heartbeat through electromagnetic pulses. Then there are the glacimeters, GPS sensors on icebergs tracking ice mass movement. When a Greenland iceberg moves faster than normal toward the Atlantic, it means ice is melting more rapidly. Every iceberg is a messenger bringing news of the Amoc's fate. All this data converges in climate supercomputers, machines that can perform 100 million billion calculations per second. The European supercomputer Lumi in Finland dedicates 30% of its power to ocean models. Every day it processes terabytes of data to understand if the Amoc is still alive. It's this technology that has allowed us to see the Amoc weakening in real time. It's thanks to these eyes in the depths that we know we're on the edge of the precipice. Lessons from the past. The younger Dryas. Earth's history offers us a troubling example of what happens when the Amoc collapses. The younger Dryas, occurring between 12,900 and 11,600 years ago, provides a chilling case study of the consequences of Atlantic circulation shutdown. It's like having a planetary-scale natural experiment demonstrating what we might face. Scientific consensus unequivocally links the younger Dryas with a significant reduction or complete shutdown of Atlantic circulation. This event shows what happens when the Amoc stops. Cooling began in less than 100 years, practically instantaneous in geological terms. But the intense cold period persisted for about 1,300 years. Greenland ice cores tell a very instructive story. In some places, temperatures plummeted 15 degrees Celsius in just 50 years. It's as if Europe went from today's climate to Siberia's within 2 generations. Ice core samples from Greenland suggest local temperatures increased by 10 degrees Celsius in just decades at the event's end, demonstrating that climate changes can be dramatically rapid, for better or worse. But paleoclimatic data reveals even more disturbing details. During the younger Dryas, North Atlantic sea ice levels extended up to 1,000 kilometers further south than normal. Iceland was surrounded by ice for most of the year. Northern France saw permanent snow above 500 meters altitude. Southern England had a climate similar to current Greenland. But the most alarming discovery concerns collapse duration. Once the Amoc shut down during the younger Dryas, it remained in an off state for about a millennium before mounting a rapid recovery to pre-younger Dryas levels. This tells us that once stopped, the system can remain inactive for centuries or millennia, even after the original cause of collapse has completely ceased. It's as if the Amoc has a memory of its off state and resists restart efforts. This means even if we completely stop CO2 emissions and Greenland melting, the Amoc could remain collapsed for generations. The global domino effect. Amoc collapse wouldn't simply be a European problem. It would trigger a cascade of planetary consequences that would transform global climate in ways that defy imagination. Like a stone thrown in a pond, climate shock waves would propagate through the entire Earth system with unprecedented violence. The intertropical convergence zone, the band of clouds and storms circling the equator, would shift southward by about 700 kilometers, drastically weakening monsoon systems that feed billions in India, West Africa, and the Amazon. We're not talking about a gradual decrease in rainfall. Indian monsoons could reduce by 20 to 30%, leaving 1.4 billion people without water. The African Sahel, already on the edge of survival, would see precipitation plummet by 40%. Countries like Mali, Niger, Chad would become even more arid. Subsistence agriculture feeding 200 million people would collapse. The result? Modern history's greatest humanitarian crisis. These aren't gradual changes. Paleoclimatic studies of the Younger Dryas confirm a wet climate in tropical South America during that period, providing evidence for a gradual northward migration of the ITCZ that precedes poleward shifts of the westerlies and polar front in northern high latitudes. Stopping ocean currents could also dramatically increase sea levels among the American Atlantic coast. The mechanism is complex but devastating. The Amoc normally creates a slope in Atlantic sea level, with water higher in mid-ocean than along coasts. When the Amoc stops, this slope disappears and water redistributes, causing sea level rise up to 1 meter along America's eastern coast. New York, Boston, Miami would see their coasts submerged faster than predicted by any sea level rise scenario caused by simple global warming. Manhattan could lose 15% of its land area. JFK Airport would regularly be underwater during tides. We're talking about a double blow. While Europe plunges into ice, the American coast goes underwater. The Amazon represents perhaps the most catastrophic consequence. Already under stress from deforestation and warming, the rainforest would see its rain patterns drastically altered, accelerating transformation from rainforest to savanna. The planet's green lung would stop absorbing CO2 and start releasing billions of tons of stored carbon. The numbers are frightening. The Amazon contains about 150 to 200 billion tons of carbon. If even just 20% were released during savanna transformation, it would equal 10 years of current global emissions. It would be a catastrophic positive feedback that could make global climate change irreversible. Marine ecosystems and fisheries would enter a state of total upheaval. The Amoc doesn't just transport heat, but also essential nutrients for marine life. Its collapse would destroy ocean food chains, causing mass extinctions and the collapse of global fishing industries. Europe's fishing industry, worth 20 billion euros annually and employing 350,000 people, would practically disappear overnight. A possible collapse timeline. Scientists have traced a disturbing timeline of how Amoc Collapse might unfold. As we've already said, it's not a switch that turns off overnight, but a gradual process that accelerates until becoming irreversible. Years 2025 to 2030. First signs, the Amoc drops from 15 to 20 sphere drops. European winters become harsher. London sees first significant December snowfalls. Amsterdam records minus 10 degrees Celsius for the first time in decades. Media talks about weather anomalies. Years 2031 to 2035. Acceleration. The Amoc plummets to 8 sphere drops. Winters become brutal. Paris under snow for 3 months. Berlin with average temperatures of minus 8 degrees Celsius in January. The Baltic begins freezing completely. First internal migrations. 500,000 Scandinavians move south. Years 2036 to 2040. Point of no return. The Amoc drops below 4 sphere drops. This is the actual collapse. London records minus 15 degrees Celsius average in January. Amsterdam minus 20 degrees Celsius. The North Sea partially freezes. Northern Europe agriculture collapses. 10 million climate refugees move toward Southern Europe. Years 2041 to 2045. The New World. The Amoc stabilizes at 2 to 3 sphere drops. Northern Europe has become Arctic. London with minus 18 degrees Celsius average winter temperature. Oslo at minus 25 degrees Celsius. The Baltic Sea frozen 8 months a year. 50 million Europeans have abandoned their homes. The EU as we know it no longer exists. This timeline isn't science fiction. It's based on sophisticated climate models and paleoclimatic evidence from the Younger Dryas. What makes it all more terrifying is that it could happen even faster. The costs of catastrophe. How much would Amoc Collapse cost? Climate economists have calculated the total economic loss for Europe would be 50 to 100 trillion euros in the first 50 years. To put that in perspective, it's 3 to 6 times the current GDP of the entire European Union. European real estate is worth about 30 trillion euros today. With Amoc Collapse, properties in Northern Europe would lose 70 to 90% of their value. Houses worth 500,000 euros today in Oslo or Stockholm would sell for 50,000 euros, if you could find anyone willing to buy them. European tourism, worth 500 billion a year and employing 27 million people, would collapse. Who would vacation in London with minus 20 degrees Celsius in January? The wine industry, symbol of Europe, would see 60% of vineyards become unusable. Burgundy, Champagne, Chianti, names that could become just memories. The European insurance industry, with assets of 10 trillion euros, would go bankrupt. No company can insure climate risks of this magnitude. The banking system, with mortgages on worthless houses and loans to non-existent agriculture businesses, would collapse. But the human cost would be even more devastating. 100 million European climate refugees would seek new homes. The cost to manage this migration? 5 to 10 trillion euros. Just to build emergency housing for 100 million people would require 2 trillion euros. A possible conclusion. What we've reported is based on real data and computer simulations, but it's still just a rough prediction. Whether we should consider it a real threat or just a benevolent warning from the planet will depend on how the Amoc behaves in the next decade. Anyway, it's another environmental problem to monitor and absolutely not to be taken lightly.